Hi friends, I am Ashok Kumar Gupta. I am starting a video tutorial for the digital system design. In this tutorial, we cover all the example used in digital system design using VHDL language, which is useful for the student of the different colleges like NITs and other private college. It is also used for the placement purpose in core field for the electronics and communication student. Now I am going to start my first example. Example number 1. To design and simulate all the basic gates using VHDL language. First we go for the theory portion of the gates. It is a basic AND gate and the boolean expression of the AND gate is A and B. This is NAND gate. This is the symbol of NAND gate, and this is the truth table of NAND gate, and this is the boolean expression. OR gate, this is a symbol, truth table and boolean expression of the OR gate. Similarly, NOR gate, XOR gate, XNOR gate, and last one is the NOT gate, a inverter. It is a single input and single output. Now we are going for the coding. To start the coding in VHDL language, first we know the input and output of the circuits. We introduce basic AND gate. In AND gates there are two inputs A and B and one output Q. So to start VHDL language, first we start the keyword entity. Entity is a keyword. To start any VHDL language, we use a entity keyword. Now we give the name of the circuits or name of the design. I am giving the name of the design basic gates and is also keywords. Now we are defining a ports. In these circuits, 3 ports are available. 2 ports are input. So A in is also defined. It is working as input, a output, and steady logic also defines the data types. Like C language, if we define a variable, and then we provide this variable is an integer, character, array type. So in VHDL language, we also provide a variable which data types like bits, steady logics, and this is the INT basic gates. In this portion, we only define the inputs and outputs. Variable Q is a bus type because in this module we cover all the basic gates. We have 7 basic gates: AND, NAND, NOR, OR, XOR, similarly NOT. This is a vector type, steady logic underscore vector 6 down to 0. So variable created by this line by Q0, Q1, Q2, similarly Q6. Now we further proceed. Similarly, next is architecture modeling of the basic gates. This is a name. We given any name of this architecture. Main entity is basic gates, and this is the sub part of basic gates. Now we are proceeding for like AND gate Q0. This is a operator for assigning this value A and B. Similarly, we design all the basic gates. Q1 assigning A or B, Q2 NAND gate, Q3 NOR gate, Q4 is the output of XOR gate, Q5 is the output of XNOR gate, and Q6 is the output of a inverter. And at last we end in the module. After ending, if we give a different name architecture, like we give the name of data flow of basic gates, then ending of this will be using by data flow. Implement through Vivado 2016.2 version. To implement this in the Vivado 2000, first we create a new project. Next, I will give a name project 1, and this is the location where you want to save your project. Next, we done for RTL project. We going to RTL project, create files. This files is known as give the basic entity name, basic underscore gates. Here we select the language. I am doing VHDL language, so selected VHDL language. Next, skip this, skip. Here we select the board. अगर हम किसी सर्किट्स को अपने हार्डवेयर पे इम्प्लीमेंट करना चाहते हैं तो किस बोर्ड पे हम उसे सेलेक्ट करना चाहते हैं, हम वहाँ से बोर्ड सेलेक्ट करते हैं। तो उसके लिए हम क्या करेंगे, अभी हम रेंडमली इसको क्या कर रहे हैं कि कोई भी रेंडमली एक बोर्ड सेलेक्ट कर रहे हैं। इसको हम लास्ट में भी चेंज कर सकते हैं, जिस बोर्ड के अकॉर्डिंग हमें इसको बर्न करना और अपना हार्डवेयर इम्प्लीमेंट करना उस पर हम डिज़ाइन कर सकते हो। नाउ अभी मैंने रेंडमली कोई भी बोर्ड सेलेक्ट कर दिया। फर्दर नेक्स्ट एंड फिनिश। इट टेक्स सम टाइम। Here we provide the input and outputs. If we know the input and outputs, then we also provide here. Otherwise, just OK and write the code in editor bound. I know the input and outputs because it is small circuits. So Q is a output, and I am defining Q as a bus of 7 bits. So this is a 6, and similarly MSB will equal to 6 and LSB equal to 0. Now our entity will be created, basic gates, and on double click editor window will be open. In editor window, here we provide the name, date, and which type of project will be created. And here is the library, inbuilt library IEEE is inbuilt, and this is a package where we use 1164 std_logic_1164 package. In this, basic gates will be included. In VHDL language, if we want to design any circuits, library will be added. I am copy the code, so to save the time I am only paste. Now save the code and we go for the simulation. Here different type of run. First we go for the run simulation to check our circuit will be correct or not, the function of the circuit will be correct or not. It will take some time, so please wait. Here the waveform window will be opened. Now right click on A. There are two type of value will be provided, force clock या force constant. Let we apply force constant on A. Select binary value. I will force value 1, 0. For B, right click on B. Force clock, binary. Leading edge value 1, trailing edge value 0. Here we set the duty cycle 50%. Here is the time period, provide the time period. Now we go for the run. Run for all, run for infinitely times, and the code will be run, and this will be used for the run for the particular time period where we set seconds, milliseconds, micro, nano, and picosecond. So we will run, and here they will the value, and we give B as a clock, zoom out, and here is the value. If Q0 is a AND gate, if E equal to 1, B equal to 0, the AND gate output will be 0, and Q1 will be OR gate output, and we provide a Q as a bus. So MSB 1010110 is at 56 7 bits. Now we go for the schematic. So for schematic design, we go for the open elaborate design. Netlist will be generated, RTL netlist will be generated. It takes some time, please wait. Our design will be, RTL design will be generated. Here A and B is the inputs, Q as outputs from 7 bits. First will be Q0 is a AND gate, this shows the 0 1 2 3 4 5 6. Q0 is a AND gate, Q1 is a OR gate, Q3 Q4 XOR gates, OR, and this is RTL inverter. This is our basic code. This will be schematic, and here is the waveform. Thank you.